We are Group K, made up of Aiden, Benjamin, Riley, and Liam. Our group presentation is titled 3D Printing from SolidWorks. 3D printing allows one to create three-dimensional objects using a specialized printer that systematically layers material on top of itself. The printer reads a digital computer file which specifies how to layer the material to build the object. This presentation goes through the process of 3D printing a 3D model in SolidWorks. To accomplish this, we must understand what SolidWorks is. SolidWorks 3D CAD can best be described as a 2D and 3D modeling software in which one can import, create, view, edit, and export 3D models. The software includes many options of exporting 3D models, including the process of 3D printing. 3D printing from SolidWorks is the focus of our presentation. As engineering students, we need to understand the process of how to operate the potential that a tool like a 3D printer offers us. One must have access to a 3D printer. Features and costs are considerations when making the purchase. One must also have the appropriate software to 3D print. There are two important pieces of software for 3D printing: CAD and slicing software. As mentioned earlier, SolidWorks is a type of CAD software. CAD software is required for creating objects, and exporting an STL file from the CAD software is required. Material used in 3D printing is called filament. The type of filament to choose depends on many factors, including cost, the need for flexibility, durability, and heat resistance. There are potential risks associated with 3D printing. The main things to be aware of are fire hazards. Printer heating elements can get stuck on high, which could cause a fire. This is called thermal runaway. Toxic fumes, specifically volatile organic compounds and ultrafine particles, can be released into the air. Avoid breathing these fumes by ensuring adequate ventilation in the printing lab. Mechanical injuries can occur from moving parts, and electrical hazards from faulty wiring and overheating is a risk. Awareness and mitigation of these risks make 3D printing a safe practice. For printing, models must be imported or created. This process of importing is simple. When in a SolidWorks file, click the Insert button and insert a mesh. The model is likely obtained as a mesh file rather than the true 3D model. Next, the file is ready to print. To create a model, SolidWorks can be used. SolidWorks is known for being the industry standard 3D modeling software. Typically, in 3D modeling, objects are made by starting with a 2D profile and extruding or rotating about some axis until the model is complete. The final result is a 3D model that is ready to print. To 3D print a SolidWorks design, you access printing through Print 3D tool. The first step is go to the toolbar at the top of the screen. Click File, scroll down to Print 3D. In the Print 3D menu, in the Settings tab, under Printer, select a printer to use. Next, go to Print Bed Location under the Print 3D tab to select the planar face that will be used as the bottom plane of your print. There are two options: expand the Feature Manager tree and select a standard plane, or select the bottom face of the part. SolidWorks will automatically place the part on the print bed and give a preview. The part orientation can be changed with two options. Use the Model Orientation sliders under Print Bed Location to change the angle or the offset from center, or use the Orient to Fit button to efficiently orient the part automatically. To change the scale, there are a couple of options. Change the size of the part by entering the scale factor in the type box under the Scale tab, or select the Scale to Fit box, and SolidWorks assigns the largest scale that will fit in the print volume preview. Analysis tools are available in the Preview tab. Build Analysis detects overhanging faces that are larger than the input angle to identify which faces need support. The Layer Height option shows the resolution of the print to find an acceptable layer height for printing. If printing uses FDM, thickness/gap analysis is a tool that calculates wall thickness based on set layer height and the type of material selected. In Build Analysis, the faces needing support will look red on the image preview because of overhang. Check the Show as Transparent option box to see the internal faces that need support. Also, under the Preview tab, scroll down to Adjust Layer Height. This changes the thickness between each layer the 3D printer will lay down, resulting in a much cleaner option at lower thicknesses. This is also known as printer resolution and is important to the end product after the print. If printing from an FDM printer, make sure to scroll down to thickness and gap analysis. Choose your material from the list and click Calculate. Use the determined height at the top to make your print optimized as best as possible. Go back to the Settings tab or the Print 3D menu, scroll down to Save to File, choose between either STL, AMF, or 3MF platforms based on printer compatibility. The files are imported to Slicer printer software, and the G-code is sent to the printer. If print options are correct, click OK. A rapid prototyping dialog box opens to ensure the print bed is clear. The printer warms up and the print starts. If your computer is connected to a printer that uses SOLIDWORKS 3D Print API, print directly from SOLIDWORKS.
Running into technical issues or confusion is easy when using complex programs such as SOLIDWORKS. There are a number of public forums and wikis that can be used to help with all sorts of issues. Online SOLIDWORKS-specific resources such as the SOLIDWORKS user forum, My SOLIDWORKS forum, and SOLIDWORKS Connected Help are available to search issues that other users have had in the past, as well as ask your own questions if you cannot find your issue already solved. External sources such as Reddit and YouTube can also be helpful for more general questions and visual tutorials as needed. The first thing you need to do when running into errors when printing 3D parts is to determine if the error is in SOLIDWORKS itself or in the printing process. If the preview in SOLIDWORKS is error-free and matches the desired product, yet prints wrong, the error is likely in the printing process itself. Trying other apps, printing from other computers and printers, and changing the resolution scale are all possible paths to try and solve this issue. If the print preview is incorrect or does not match the desired product, then there is an issue in SOLIDWORKS, and you must look for error messages or contact support. Common SOLIDWORKS error messages include unsolvable sketch, sketches with dimensions that result in impossible geometry, overdefined sketch, sketches with redundant dimensions or relations, dangling geometry, dimensions or relations to geometry that no longer exists, and thousands more. There are many error messages in SOLIDWORKS, which is why it's important to turn to user forums and wikis to help solve your issue. SOLIDWORKS is one of the most used tools in the engineering field. Its uses are endless, and good engineers must know how to print parts from it. Following a step-by-step guide on how to print parts ensures printing will go smoothly. However, even then, issues can arise, as SOLIDWORKS and 3D printing is complicated. Using online resources and forums will allow for navigation of possible errors and how to fix them. Using the step-by-step guide to print and online resources for error solving will ensure a smooth printing experience.